Assuming, listen, I lied to you when I said that you always just have to make the top equal zero. That is not true when there's something after the function like this. Okay? So when I said that, I was out of line to say that because I said it with such gusto that I would have led you to believe that that's always what you do. But in this case, you cannot make the top equal zero, so you would be inclined to say that there's not an x-intercept. That is just not true at all. So the thing about set the top equal to zero applies to rational functions when there is just a top and a bottom and nothing else. Got it? So like problems 2, 3, and 4 on the practice quiz, that would apply. Okay. Look for all your factoring, cancel stuff out, and then anything left that can make the top equal zero is an x-intercept. Having said that, we need to investigate problem 1. So here's the deal. An x-intercept, I really need you now listening. An x-intercept is where a graph crosses the x-axis. And if you're crossing the x-axis, then by default, your y-coordinate has to be equal to zero, correct? And we know enough about math by now, I think, to know that when I say k of x equals, really what I'm saying is y equals, right? And so if it says y equals, but I understand that I need the y coordinate to be zero, then I can go a step further and I can change this y into the number zero. You normally don't have to go to these lengths. Again, this only applies because of the thing I've circled in red. That guy is the one that messes everything up. So what we're going to do now is we're going to solve this equation. We're going to use some pretty simple algebra to solve this equation. What would be the first thing that we would do? We would add 3 to both sides. So we're going to get, if I add the 3 across, I get 3 equals negative 2 over x plus 1. What's next?
The multiply by x plus 1.
Yeah, I mean, you could lose the negative, but honestly, the best rule of thumb with something like this is C fraction, kill fraction. So in math, if you have an equation and there's a bottom, if something has a bottom, by definition, it's what we call a fraction. And if you want it not to be a fraction, which you should want that, then you're going to multiply by whatever's on the bottom. So I'm going to multiply on both sides by x plus 1, like this. And again, I'm doing all of this for the specific reason of finding x-intercepts. X-intercepts are where y equals 0. So by forcing, you do so much of that in upper level math, is that you just force something to be true. You want it to be true, force it to be true. Write an equation that forces it to be true. So if I multiply both sides by x plus 1, these x plus 1s on the right side cancel out, and I'm left with a basic distribution problem on the left. What do I get?
3x plus 3.
So I get 3x plus 3 equals the leftovers, negative 2, because the x plus 1's canceled out. And then we would, of course, subtract the 3. This is where just our basic algebra training kicks in. The 3x just stays. The 3 goes to the other side, becomes negative 5. And then we divide both sides by 3, and we get x equals negative 5/3. So what this means is that there is an x-intercept at the point negative 1 and 2/3, comma, 0. Remember that x-intercepts go x number, comma, 0. Y-intercepts go 0, comma, number. Got it? I feel like I'm having deja vu, like we already talked about this, but I don't know if it was a whole class discussion or if that was just between me and a few people.
Gives a whole.
Let's go to practice quiz number 2 real quick while we're here, while I'm recording, and let's take a look at the same situation, but on practice quiz number 2. So on practice quiz number 2, we have k of x, the negative of 4. Is that a 4?
Yeah,
the negative
Yeah. Of 4 over x minus 3 plus 2.
Good. So if we're finding an x-intercept, our job is to wipe out this function side, the y equals side, and call it what it is, what we want it to be, 0. And then let the algebra instincts kick in. What do we do next? We subtract 2, giving us negative 2 equals the negative of 4 over x minus 3. Next, kill the fraction, which means we're going to multiply both sides by x minus 3. And it just boils down to some pretty basic algebra at this point. So what do we get over here on the left? Perfect.
No.
Equals. Good. And then you solve. Subtract 6, right? You get negative 2x equals, and then divide by negative 2. That means that the graph will cross the x-axis at the point 5, 0. Rad, right? So with convenient, clean top-bottom rational functions, yeah, just set the top equal to 0. With these annoying ones that have the vertical offsetter, you got to do a little extra grunt work there. Got it?
Yeah.
All right. Recording well. It was time well spent. Yeah, I think.
You want us to have.
Zane dropped a bomb last week when he pointed out that we can change our delta table from inside the table. Zach just dropped another bomb. When you go in your graphing calculator screen to where it says like y1 equals, if you push, so the stuff you guys figure out. If you push alpha, the green button, and then push the variable button right next to it, it actually creates a top-bottom fraction for you, which is really cool. And it doesn't even say on there. Zach must have just been, it was like an accident or something. But the fact that you can do that means that you can now type all your stuff into the top and then just move your cursor and type it all on the bottom. Moral of the story is no parentheses necessary. So like if you want to type in like x squared plus 4x minus 8, and then you just cursor down and you can do like 2x squared minus 3. That's really cool. Thanks, Zachary. That saves some stress when it comes to parenthesization. It's not a real word. Thanks, Zach.
Last week we would make mess